Good morning. Thank you. Thank you. Okay. First of all, I would like to express my gratitude to the organization HPC Advisory. Sydney, thank you for your support and help. And also to my colleagues from Barcelona Supercomputing Center, Universidad Politécnica of Valencia, Docker and Mellanox, to bring us the opportunity to sponsor this meeting today, and we are very proud of it. Okay. Going to the topics, I will, in brief, I will try to explain the history of Fujitsu and HPC, what is our long history in HPC. I will talk about high-end HPC platform, post-FX 100, our first exascale era system based in ARM. Okay. Then I will talk about Intel architecture-based solution, especially I will talking about the new immersive cooling solution, okay, that we are developing. And I will deserve some time for newer processing technology that we are developing for the post-Moore era, like artificial intelligence, deep learning, and quantum. Okay, so let's try to enjoy this talk, okay? First, some numbers and history about Fujitsu. Fujitsu is one of the largest IT companies in the world. We are founded in 1935 in Japan, and our headquarters are based in Tokyo. We are the largest IT service provider, one of the Japanese largest IT service provider, the number 5 in the world. We have factories in Japan, in Asia, Europe, North America, and we have global delivery centers in all the world, in Europe, in Lisbon, in America, in Costa Rica. We have a lot of people there. In total, we are 155,000 employees, and we attend or serve customers in more than 100 countries. And one important data is that we spend every year $2 billion in research and development, innovation, research, and development. Where we will work, and this is very important in the context of the Euro HPC initiative, we are very strong and a very big number of persons in the world, but especially in EMEA, we are 28,000 people working in EMEA, not only in factories, also in service, and we are very strong. Especially in Spain, we are close to 2,000 employees. And big part of our company is a service company, okay? Doing maintenance, support, and whole services. I will explain that. Additionally, we have one Fujitsu Laboratories organization, and Fujitsu Laboratories is an organization that have different offices in Sunnyvale, in Beijing, in Japan, in London, but I'm very proud of our Madrid office of Fujitsu Laboratories with a strong focus in data analytics, big data, and artificial intelligence solutions. This happens in Madrid, in Spain. Our European roots are very strong, and one of our singularities that we have our Intel servers factory in Augsburg, in Germany. So we are a made in Germany, made in Europe provider. Okay, so when we produce one server, one workstation, one notebook, this is we are creating jobs in Europe. Okay, and this is very important message. Okay, our capabilities that we can produce 12,000 workstations per day, 950 servers per day, 50 racks, and 8,000 motherboards per day in this factory in Augsburg, 80 kilometers from Munich. Okay. Our portfolio is very strong. We represent this area that includes servers, storage, networking, software, client computing device, and services. Okay. But all our company makes a lot of things, including data center services, support services, consultancy, and application modernization programs. So we have a lot of activities, okay? And now the HPC structure. Usually the people think in Fujitsu and think in Japan, but in Europe, in Tokyo, of course, we have our strong army. We have the Technical Computing Solution Unit that employs around 400 people in this unit. And we have another unit called Next Generation Technical Computing that employs 400 people more or less, fully dedicated to supercomputing and technical computing techniques. In Europe, we have different locations. In Toulouse, we have a team dedicated to the middleware and software stack in HPC. This team was created to support Airbus. Okay, that's the reason because our team is based there. Okay, 25 years ago. We have in Munich, we have a strong team. London and Wales, another big thing in HPC. And of course, I'm proud of my team here. We have close 20 people in Madrid. Madrid, Barcelona, Valencia. We have a virtual team, a distributed team. But we are able to do end-to-end solutions for HPC to any customer in Spain. Doesn't matter if in the continental area or in the islands, Baleares or Canary Island, but we can cover. We are one of the companies that in Spain can provide support services with people in Canary Island. This is very singular. When you, and now we have one story over the Cherenkov telescope array that we have to deliver one supercomputer in a container together with the telescopes, and we have 2 people living in La Palma Island. This is very strange that you find one company that have people living there. Okay, one IT company. Okay. How we work in the HPC area is mainly virtual teaming. Our lead is the Japan organization, and we have the links with France, Germany, and Spain here in Europe. We support also to our Italian and other countries in Netherlands college, but especially from the Germany, France, and Spain. We have one competence center in India, okay, and this is another important part. Our benchmark center is delivered in India, and we have our Fujitsu Laboratories organization. A part of our own organization that is the responsible to manage the alliance with partners like Mellanox or Intel or Altair, or these partners in software side. A part of this organization, we count also with our network of partners, and we have a specific certification for HPC partners that is called Expert High Performance Computing. All partners that have, all companies that have this logo is a certified partner for Fujitsu, specifically for HPC. Okay. One part of the story, what did you know about Fujitsu in the past? What is your story about Fujitsu? Do you remember Andal computing? The mainframes, the world, the story, the beginnings of the story of the computing area? With IBM, Andal, and all this story? Fujitsu was part of this story because we created the first mainframe in Japan and the first relay computer, Facom. Okay? And we finally, Andal, sell to Fujitsu, his company. So that was our mainframe origins. And based on it, we created our vectorial processing line. We created the first vector array processor machine in Japan in the 18th. And this is the background in Spain. 25 years ago in Sesga, the biggest machine in Spain was a vectorial processor machine from Fujitsu. It was the number 1 supercomputer that we have outside Japan. Okay? And this is our origins, vectorial processor, very, very important point. Then, in 2011, this line is original based in Spark processors, and we, in 2011, November 11, 2011, 11, okay? at 1111 in the top 500, we was the number one with K supercomputer. That was the first machine that surpassed 20 petaflops, 11 petaflops, real peak theorics. That's very magic. You don't see these details, but try to look for the list in 2011. And we delivered the K supercomputer. K supercomputer is this amazing machine, building, customized and created from the scratch from Fujitsu. Okay, based in a Spark processor, is hosted in the Kobe Island. And you can see this machine is beautiful because it's a building with 6 floors. The supercomputer is in the 6th floor. Remember Japan and earthquakes? Okay, and there are no columns because they want that the machine will be like a theater. You can see the whole machine from the crystals. It's amazing. So I invite you to visit Kobe and to visit the Riken Center where this machine is hosted. It's beautiful. Based on our, curiously, all the people talk about top 500, Limpa, number 1 in Limpa, yeah. We are yet one of the best machines in the world in the Graph 500, in the HPCG, in the Green 500. If you look all the benchmark that doesn't measure in Limpa performance, that isn't real efficiency in applications, this is how well you execute a multiplication of linear algebraic matrix, okay? That is Limpa. And at the end, we are not, we are in the top 20 if we can yet, okay? Again, I repeat, 2011. But we are number one, number 2 yet in 2011 with this machine, 2018 with this machine. But based in this know-how, we created the successor FX10 and FX100, and we are designing and building the next machine, the exascale is not good definition, but the exascale era machine that we are building for 2020, 22, okay? And in the general purpose projects, we have an Intel processor line, and this is also, I will mention later, okay? Let me talk a bit about our POST-K project, okay? First, our POST-K project is a national project from Japan. In the world, there are 4 flagship or 4 big exascale projects. The USA program, the Chinese program, the China program, the European Euro HPC program, and the Japanese national project. Okay, this is the budget from the government of Japan is close to $1 billion. Okay, to create all the elements necessary to have one exascale era machine. Okay, and the vendor selected to create this machine is Fujitsu. Okay, the customer is Riken, or the organization leading this is the research organization is Riken, but the vendor partner selected is Fujitsu. Okay, so we have the mandate to create this machine. Okay, a part of the pure machine, the researchers in Japan are working in the applications in 9 strategic topics: life science, manufacturing, society, different high strategic topics to improve and to improve the efficiency of applications in this machine. This is the real focus and the real target of the Japan initiative. It's not about to bring huge number of flops. That's great, okay? But the main target is to have a real efficient machine, not only in gigaflops per batch, also in the efficiency of application. This is the target, okay? And what we are doing here is to inherit some of the technologies that we create already for K supercomputers. So we are evolving this technology during the time, okay? One of the most highlight topics and the people is talking about is our ARM processor. A64FX is the name of the processor. Okay, and we announced this in Fujitsu conference in August 21. We made the announcement of the processor and we showed some specifications of the processor there. So let me talk about the processor. We decided to use a low energy specification, ARM, and we introduced some extensions to ARM specification in order to improve ARM for HPC workloads. One of the most important workloads that we will support is scalable vectorial extension, vector machines, scalable vectorial extension, and variable vectors in ARM technology. That brings to the ARM technology the possibility to multiply or to sum rows and columns like a vector, not a single number. So this is one of the things where we are working, but we are putting more things on ARM, okay? We are also collaborating with Linaro. We are working with the community of open source to improve all the compilers, debuggers for this processor, okay? And we are contributing this to the ARM specification. So our aim and the ARM aim is that this become one standard for the HPC world, okay? Some details about the processor. The processor is a 48 cores. This is the compute cores, but we developed something called the assistant core. What is the function of the assistant core? The classical cores are compute cores. So we try to move the non-compute tasks to the assistant core. For example, I/O tasks, MPI tasks. This kind of tasks will not be affecting the rest of code. This core is dedicated to compute, okay? And this rest of function we will make by the assistant core, okay? And we create inside the core in memory group is 12 plus 1 assistant core, so we divided the processor in 4 areas, okay? And these 4 areas create like a coherent NUMA interconnect inside the processor, okay? The other important aspect is we have the interconnect integrated in the processor. I will talk a bit about TOFU now, but it is the specific interconnect that we will use in K supercomputer and the evolution to post-K, okay? But all the interconnect is integrated in the processor specification, okay? If you see the evolution from the K, FX10, FX100, and post-K, okay, we extend the length of the word to 512 bits, and we increase this, but especially we make one good job in the floating point in 8 bits and 60 bits instruction, and also in the integer part of the processor. Why? Because artificial intelligence and big data application, high performance data analytics applications needs this kind of register. Doesn't need a 32 bits or 64 bits. And we are improving this processor also to these workloads, like artificial intelligence, learning, big data. It's a generic purpose processor, but not only thinking in floating point, dual precision workloads, okay? So it's more generic, okay? And a part of the hardware side, we are developing the processor and the full machine, the racks, and this is a work that we are doing at this moment. We are in the development phase. We are building, together with Riken, the full software stack for the machine, including a parallel file system based on Lustre, called Fujitsu Laboratories file system, okay? All the management software needed and all the programming environment, like compilers, debugging, libraries, to this machine, okay? So there are This is not only made in Japan, we are co-creating together with customers. For example, we have an exascale agreement with Barcelona Supercomputing Center, and we are working together with the teams of ROSA together to improve some of the software stack for this platform. Okay, this some of as you can see, it's not only a Fujitsu innovation, we are together with the community and with the researchers in the world working to this platform. Our aim is to support the creation of one ARM ecosystem in Europe. This is what we want to do together with you. Okay. Regarding Primergy, okay, is we have a full range of servers. I don't want to spend a lot of time in the details of all the formats that we have, but especially we have one specific format for HPC, cloud and technical computing, that is the high density servers, that is CX. What I try to show here is what is the server that we use depending in the HPC cluster, what is the function of the server that you need to use. A login node, a heap node, a fat memory system, and this is the standard servers that we are doing. We are working together with Intel to improve these servers, and in the European Union, we have one of the European funded programs called Next Generation IO, Next Gen IO, to create the servers with non-volatile memory architecture. This is a European Union program where the technological partners are Intel and Fujitsu. And there are more partners like Edinburgh, BSc, and research partners, but we are developing the hardware with this characteristic in Europe, okay? Well, this is some of detail. We have some nodes to support NVIDIA GPU cards. We have, in the same chassis, we have only CPUs, and we can use water cooling mechanisms to this machine. This is an option. You can have air cooled or water cooled, okay? This is, we are working very intensively in the cooling aspect because we are Japanese and Germans. In Japan, the restriction, the regulation to use the energy is very strict, and we need to take very careful the aspect of cooling. I'm very proud of two projects. One is ALMA radio telescope in Atacama in Chile. The server have to work at 5,000 meters of altitude. At this level of altitude, you don't have the same level of pressure in the air, so the spinning part in the servers can fail. Okay, so we deliver servers in very, very heavy conditions. Okay, La Palma was another good example of this. Okay, but we put a lot of attention in the cooling and energy dissipation aspect. We have a lot of patents and things working on it, okay? Liquid immersion cooling, okay? Last year, based in our experience in other projects in Japan is very focused in efficiency, in green efficiency. Look, the Green 500. And you see this list is full of Japanese machines. There are one Chinese machine, one USA machine, but the big list of Green 500 in the top is Japanese. Look this, Subami, Shobu, okay? And not only using GPUs, because some people, the GPUs, sometimes it's one way to achieve this kind of gigaflop per watt ratio. But at the end, how you achieve this with general purpose processor, that's the magic, okay? So what we develop is a BAP where we can host between 20, 64 servers, depending on the configuration, and some storage system that we can put inside, okay? And the BAP can be stacked until 8 bucks. So you can save a lot of space in the data center if you put this kind of buff. And a part of this is the best power user efficiency ratio. The value that you inject to the data center is consumed by the machine. So the PUE is close to 1. That is the ideal efficiency factor in one data center. So you save space, you save energy aspects, and you can improve your number for your data center. It's not about what is the cost of acquisition, it's about the TCO, the total cost of ownership. What is the cost to maintain, to operate? Because you have a lot of racks, you have to pay a lot for energy to the electrical company, okay? So nothing is free in the world. So there are all the aspects that you need to consider, the cost for operation, etc., okay? Okay, this is some of raw numbers, 40% less power, 50% less space, and we can't deliver this in a container. Where is my Docker college? And sorry, it's not software container, it's a hardware container. Okay? But we would like to put also Docker on top, okay? No? but we can deliver this back inside the container. That's for astrophysical installations. So we have another reference in computation in Spain when we have in the previous phases when the data center was built the data center. First we have to deliver in a container, and then we move the machine when the data center was finished. So, but original was delivered inside the container. The Cherenkov telescope is another example where we deliver in La Palma Island, in the Roca de los Muchachos, 2,000 meters, by the narrow way. We put the container on top of the mountain with the telescope, okay? That's amazing project. And there are not a special need for the servers. We remove the fans, okay? And we will put inside the liquid. The liquid is a dielectric, it's not flammable, it's a special liquid. In the last version we are using floating nets. This is a 3M developed liquid solution, okay? There are not a special maintenance. You can open the door and you can extract the server, extract the disks. You can do anything that you make with the server in a rack inside the bag. And you can install in existing facility. The weight is 1 ton per square meter. It's the same parameters that we use for standard racks. Okay, so there are not special needs in the data center to install this. Okay, software stack. We are contributing, or we are part of the Open HPC consortium. Open HPC consortium driven and pushed by Intel especially. We will join as a partner. Our team in Toulouse is part of this development, and we are adapting all our middleware stack following the Open HPC standard. This part, I think that Open HPC is part of the Linux Foundation. Yes, Open HPC is part of the Linux Foundation, and we are doing us and the rest of leaders in the industry in HPC is try to create one standard of software stack. This is a work in development. Okay, and this is all the elements that this Open HPC initiative is covering. Okay, we are contributing, or we are proposing to use our HPC gateway. This is a software solution to bring one HPC desktop to any user, non-classic, non-technical HPC user can use HPC application from the desktop. You have a simple interface, and you can launch workflows, you can launch applications, you can put parameters with an easy-to-use interface. This is some of the contributions that we are doing here. Newer processor solution. I don't want to be visionary here, but I will talk about the future, okay? So, deep learning solutions. Of course, we have a strong partnership with NVIDIA. If you see the top 500 in the number 5, you see the ABCI machine. It's a big machine for artificial intelligence in Japan. This is delivered by Fujitsu and NVIDIA, okay? And we have this big machine in Japan, okay? But additionally, we are developing one specific processor for deep learning with some extension and some change that Fujitsu considered that this kind of workload needs, okay? For this reason, we are creating this kind of processor architecture that includes HBM2 memory and interconnection on the chip, and one structure to manage the learning processing, neural network processing architecture. Our first version is a PCI Express card, but our aim is that will be a host-based processor in the future. Okay? I can give more detail at this moment. And of course, this is the visionary part. The Moore law is reaching the limits. It's very complicated to goes down and down and down in the semiconductor era to produce processors, because the limits of 10 nanometers, 7 nanometers, 5 nanometers, 3 nanometers is reaching. We are achieving the limits. So we need to look for new models of computing, neural computing, brain spirit, quantum, and we need to look for new models. And at this point, we developed something called digital annealer. What is digital annealer? It's something to solve combinatorial problems. Okay, that's the quantum model solve. But the fast track for Fujitsu is we developed this based in semiconductors. So we have something like a quantum that can be used at environmental conditions. We don't need to go to 0 Kelvin degrees, okay? Because it's a semiconductor with the logic of quantum. And this is called a digital annealer unit. This doesn't solve all the quantum problems in the world, but we can solve a lot of problems in life science, in finance, in energy, together with our partnership with the Toronto-based company called 1Qubit. Okay? And yesterday we make a press release that we announced a partnership with Waseda University in Japan for this technology. Pay attention to DIU. It's another interesting technology. Finally, my last slide, a summary. We are developing 3 interesting technology, ARM for our flagship project for our exascale HPC technologies, deep learning processors for artificial intelligence workloads, and digital annealer unit for quantum models for combinatorial problems. Okay? This is the 3 lines that we are working at this moment in the semiconductor area. Okay? So it's very interesting to follow the evolution of the 3 lines. And finally, this is my summary. We have a complete HPC solution portfolio. We have a worldwide HPC competence network, not only Japanese. You can see I'm not Japanese, I'm Cuban. But the point is, we are, in the world, we are not only a big experts in Japan, also outside Japan, we have a team of HPC experts. We have a research and development center, and we have the desire to co-create together with our customer, not only innovation from Fujitsu with the customer. So we co-create together. So this is the final word in my slides. If you have any question, please.
Yeah, on the DAU, can you
Yes.
go back to that slide showing all the combinations?
Yeah.
There you go. How much faster is it using your DAU processors opposed to standard?
This is a work in progress. Currently, we can simulate 1024 qubits, but our target is that we can achieve 10 times more in short term. The thing is, this is a very pragmatical approach, because what we use was the conventional semiconductor areas, and we create the software stack to do the annealing function. So it's a short route. to,
So
to
10x is kind of the target at this point?
10,000 qubits in simulation. It's not something that you can use for generic algorithms, because one of the most important things, and this is a word for all of you, that important work to do in the algorithmic side, okay, in the science of the algorithms to be adapted for the quantum era. So we are, the number of people in Spain, for example, able to program for this environment is very, 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 very limited. So if you are thinking in your future, think in to try to develop in QDK, in QChark, in this kind of middlewares to develop software for quantum, because it's a new programming model, so you need you have a space for development here. Okay, we are doing some pilots with customers in the life science area, drug discovery and logistics companies for achievement of transport and finance. In Japan, we have some pilot project working in banks, in big banks in Japan. Finish. No more time.
Any more questions?
Any question? Well, I will be there, so if you have any question, it will be my pleasure to answer you. Okay, thank you very much.